All right, so today we're going to look at calculating the area of a triangle. This is something that you've looked at in middle school and maybe even brought up in Algebra 1. We know this as area equals 1/2 base times height. The thing I really want to point to is the start thing is that we're looking at perpendicular distance, because most of the time when you were in middle school or Algebra 1, the teachers focused on right triangles, so the height was very distinct. What we're going to look at today is, registering it, whether it's there or not, and where it should be. So what I mean by that is we're going to look at the perpendicular height. It could be very obvious what it is, or sometimes we might even need to find it using something like the Pythagorean theorem. So the first one, it says find the area. And this is what I was saying. This is the type of example you do in middle school, right? You clearly see this is a right triangle. So this is my base, and that's my height. It's very distinct what the base and height are. So if I did area equals 1/2 base, which is 5, height, which is 6, then I do 1/2. I'm going to multiply these first, so 1/2 times 30, and I get area is equal to 15. And again, don't forget about units, centimeters squared. We get 15 centimeters squared. Those are the ones that you focus most on middle school, right? Right triangles with right angles. So here's another example here, finding the area. Again, it's pretty distinct that this is our base. What you'll notice here is that I have a perpendicular line or a right angle formed from the base of my triangle to the top of the triangle. In this example, this would be our height in here. So I have area equals 1/2, the base is 18, and the height would be 6. Feel free to use a calculator, right? I'm going to do 18 times 6 first. You can plug it all in at once. That's going to give me 108. So area is equal to 1/2 times 108. And if I multiply that, I get 54. And this one doesn't have units, so I'm going to write units squared. Right? So again, pay attention that if it's perpendicular, like it's clear that it's a right angle from a right triangle, that's the height, or I could have it inside. What we're going to look at now is, well, what if I have a triangle with a perpendicular height outside, right? I could take this as my base. And if you notice, the height is registered by perpendicular distance, as we said before. So this value over here, that 6.5, is going to represent the height. It could be located on the outside depending on where the tip of the triangle is. You just have to pay attention to that. So I have area equals 1/2 times 5 times 6.5. Right, and again, I'm going to pay attention to multiplying these two first. I can use a calculator. So 5 times 6.5, 32.5. So I have area equals 1/2 times 32.5. And now I can multiply this times 1/2. What I'm going to do is just hit times 0.5, and I get 16.25. I have centimeters again, so I'm going to do 7 meters squared, and I have my area. If you look at this example again, the height could be a perpendicular distance outside of the triangle. Just pay attention to that as another example for finding the area of a triangle. The last one I have here is actually, different, right? I have my base here, which is obvious. If we looked at this right triangle as like we did for the example up there, this would actually be my hypotenuse, which doesn't really help me, right? I need to know what this is. But the best feature about this is that this is a right triangle, meaning I can use something like the Pythagorean theorem to solve for, let's call this h. So what I'm going to do is Pythagorean theorem, h squared plus my base, which is 12 squared, is equal to 13 squared. Some of you guys also might notice this is a Pythagorean triple from the get-go. Feel free to write that in. I'm just going to show it all the way out. I have h squared plus 144. 13 squared is going to give me 169. Subtract to solve for h. And I'm going to get h squared is equal to 25. Of course, take the square root of this. And now I know my height is going to be 5. Right? That value right there, the height is going to be 5. So now we have our values. Sometimes you need to go find them. And as you move forward, you're going to see that, sometimes you might be given the area, you need to find base. Sometimes, we're not going to be given a right triangle. We might be given a degree measure, so you might use trig. For this example, we had to use Pythagorean theorem to solve this. So now we know the height. I'm going to solve for the area. I have the base as 12. I have the height as 5. And now I can just simplify and solve this. 12 times 5 is going to give me 60. And 60 times a half is going to give me 30. Let me scroll up for you. And for this example, there's no unit, so I'm going to write units squared. So the biggest thing to pay attention to here, guys, is this idea that perpendicular distance is going to represent height. We could have it as a right triangle. It could be inside of the triangle. It could be outside of the triangle. And sometimes that height or even the base could be missing, and you have to use something like the Pythagorean theorem to find it.